Our next speaker will be Tracey Butchart. And Tracey Butchart started her career in 1986 teaching maths and science to privileged Joburg teenagers by day and hardworking adult domestic worker by night. It was this divide that inspired a mission to broaden access to maths and science education through overcoming learning deficit and acquired in our school system and raising achievement for all. Ladies and gentlemen, let's welcome Tracey.
Very much for the opportunity to come and talk with you. I have to tell you right at the start that Louise asked me to do this because, as strange as it sounds, my company is called Reflective Learning. And so I don't want to stand and do a sales pitch to you today. So I had to think quite carefully how I was going to prepare for it. And I thought that I would talk about the story of the development of our reflective learning solution and show you how it facilitates reflective practice, and then pull out the key components of what I think a reflective learning environment really requires. Okay, so I'm going to start with the traditional. Yes, I can see now, sorry. This traditional doom and gloom story, and I apologize, it is actually going to get better. But, you know, the global perception is that we are at the bottom of the heap. These are the World Economic Forum indexes from a couple of 2 years ago now, and it is a perception, this. But unfortunately, it is borne out by some of our results. And these are the ANA results for grades 1 to 9 through to 2014. And it's shocking to see that 11% is the average achieved by the grade 9s on that annual national assessment in 2014. Sorry, that sounds a bit better. I think for me, what's really even more worrying is that 3% of grade 9 learners are actually achieving above 50%. So access to maths and science in FET is limited. A child who can't pass maths and science in grade 9 is not in a position to even choose to take the subject in grade 10, and that is of great concern to me personally. Whoops. Okay. The reality is that those that do choose to take maths and science who are eligible are still struggling to achieve good results in grade 12. So again, this my data is a little slow. This is 2015 results, and we are getting better. 2016 was marginally better. But you can see that only 40.9% of grade 12 learners actually write maths, actually do maths. So 60% don't do maths, and of those that do maths, we have only 31.9% that are achieving above 40%. So it is really distressing, and the roots of it go quite far back. And this is where my particular interest of research is in acquired learning deficits. And I'm not sure if you're familiar with this research. It was done by Nick Spall and Hanli Kotze at Stellenbosch University. 2015, they released this paper, which was a big wake-up call. They analyzed learners' maths results, and what they were able to see was that in schools that are rated as quintiles 1 to 4, the vast majority of grade 3 learners leave foundation phase. I don't know what that buzzing is. I'm sorry. It's I don't know if it's only me that can hear it, but the majority of grade 3 learners leave 3 years already behind. So you think they've been at school for 3 years, and at the end of grade 3, they're 3 years behind. And that's a big worry, because right at the very beginning is where the loss of access to maths and science later is actually starting. They also found that by grade 9, learners are 4 years behind. So they managed to scrape back some of those early primary school years after they've actually completed those grades. And there's a huge gap between the learners in quintile 5 schools and in quintiles 1 to 4. In fact, I think one of his final conclusions, and I don't know if I've put it up there, but 16% of learners leaving grade 3 are actually functioning at a grade 3 level. 16%. So it's a big problem, okay? That's our reality. This is another little reality I just want to draw your attention to, because I think it's one that we forget as teachers. Just because I taught it doesn't mean they learned it. And I can't tell you how many times I'm working with teachers and they go, I don't understand why my learners can't do this. I've taught them this over and over again. And actually, we actually do know that when we teach something, learners leave with many different ideas of what it is that we taught them. That's because our knowledge and our understanding is constructed by ourselves. And so the only way that we can be sure that they've learned what we are teaching is through formative assessment. And I'm afraid that is my little soapbox that I stand on. I'm a big proponent of formative assessment, the particular form of it that is known as assessment as learning, where the learner is a key participant in that assessment process. So just to quickly, this is my guru that I follow, Dylan William, who is started out he's from the UK, but most of his work now he's doing in the United States. But he is promoting the embedding of formative assessment in classroom practice to direct teachers' teaching, so that they are truly meeting the learning needs of their learners. Oops. So I thought that I would start to tell you about the journey that I've been on around reflective practice and how that actually offers an opportunity for addressing those issues that I outlined at the beginning in maths and science. So I started work on a project in 2012 called Learners for Excellence, which was based at Uplands Outreach, which is the outreach arm of a big private school, Uplands College, in White River. And what happened was that there's a very impoverished community living nearby, which falls under the Nsakazi circuit of the Mpumalanga Education Department. The area is a sort of rural community squashed between the Kruger National Park, the Kruger Mpumalanga International Airport, and the town of White River. And that circuit was the lowest performing circuit on the grade 12 2011 results. So Uplands, in partnership with that circuit manager, designed an intervention. They had funding from Rand Merchant Bank to make a difference in maths, particularly in those schools. There are only 10 schools in the Nsakazi district, and so what happened in the Nsakazi circuit, sorry, I always get the phrases back to front, and so what happened is the 5 top learners from each of those schools were selected to participate in a supplementary maths program. And I was brought in as the project evaluator for that. And when we had our planning meeting, we were going to, Uplands College wanted to run a grade 9 summative maths exam as a baseline test for these grade 10 learners. And I was concerned that actually if they couldn't do anything on that grade 9 summative exam, we wouldn't actually know what the situation was in terms of their maths understanding. So I undertook to design a diagnostic that would actually pinpoint exactly where their strengths and weaknesses in maths were and the level to which they were operating, so that we could actually implement any remediation if we needed to. So just, I'm talking too much without moving the slides on. Here's a picture of the learners. This project was a life-changing experience, not just for these 50 learners, but the 5 staff of us that were involved in it. It was really the most extraordinary experience for me personally, and I learnt so much out of it, hopefully some of which I can share with you today. So I designed my diagnostic, and I'll explain just now how I look at maths, but essentially I benchmarked grade 3, grade 6 and grade 9 level for the important components of maths, and the results were a shocking wake-up for us. As you can see, the highest achieving learner in the group got 48% on the diagnostic, and those coloured lines give you an indication of the grade level of operation. So that lowest red line indicates grade 3 level achievement, that middle yellow line indicates grade 6 level achievement, and the green line indicates grade 9 level achievement. And this is a straightforward diagnostic testing conceptual landmarks in maths. No tricks, no fancy things, no difficult stuff. It's like a scan of a learner's maths understanding. What can they and can't they do? And you can see right down at the bottom there that I had 5 learners who were not yet at grade 3 level, and they were in grade 10. And they were the best maths learners in their schools. So we had actually planned a Saturday morning supplementary classes that were going to be delivered by grade 10 maths teachers who were part of another Uplands project called Teachers for Excellence. And we had not planned in our schedule any time for catch-up. But clearly we couldn't actually deliver what we had planned because the learners were not able to take advantage of that. In fact, when I looked down at the specifics, just to give you an example, there were 50 learners. I had 10 of them who could divide whole numbers. Only 10 out of the 50. And when I say divide whole numbers, I mean learners who could say 20 divided by 5 equals 4. We're not even talking about really difficult things. So now in the grade 10 maths syllabus, you've got to teach factorizing in algebra. How do they learn to factorize when they actually don't understand what dividing is? And they can't do it even with numbers within the range that we work with every day. So we had to change our design. And what happened is they were able to free up 1 hour contact time once a week on a Saturday for me to try and fix this in the shortest time possible, because the grade 10 instruction was going to happen concurrently. So it was quite a tall order, but I actually, as I said, I am a big proponent of assessment as learning, and I used an assessment as learning conceptual thread approach, which I'm going to share with you today. Before I do that, let me just quickly show you what happened. 2 terms later, we administered the diagnostic to measure the progress that they had made, and you can see that although we don't have all the learners above grade 9 level yet, in every one of those areas, and I'll explain that now, I think, you can see the improvement has been tremendous. Basically, the way that I tackle maths and science, because I have the same system in place for science, is I've identified 7 conceptual threads that run through maths and science from grade 1 through to grade 9. And along those conceptual threads, I have identified what I call conceptual landmarks, which are important concepts that a learner has to master in order to progress with maths or with science. And so the diagnostic actually measures learners' performance on each of those landmarks. There are 81 conceptual landmarks in the maths diagnostic, just to give you an idea of that. And these are the the threads. These are my 7 threads. Numbers, fractions I separate from numbers because that's a whole challenge of its own. Patterns, functions, and algebra, space and shape, measurement, data handling, and problem solving. And problem solving is not word sums in maths, which is often the interpretation of it. It's actually logic and reasoning. So it has wider application. So just to give you another interesting little perspective that I had, about 2 years later, I ran the diagnostics with 292 learners in the Eastern Cape and Limpopo. And what was interesting about this project is that the learners ranged in age from those that were in grade 7 to those that were in grade 11. And I administered a grade 6 level diagnostic. And so that benchmarks grade 1, grade 3, and grade 6 levels. And you can see on my graph the red line is the grade 3 level, and the yellow line is the grade 6 level. And the different colored bars show the different age groups. So if you look at numbers, the most left-hand side bar, those were grade 7 learners in Limpopo. Next to it, there's quite a drop down. Those were grade 8 learners in Limpopo, grade 9 learners in Limpopo. Those are grade 9 learners, the next one in the Eastern Cape, and then the grade 10 learners in the grade 11. Have a look and see. There's no significant difference between the performance of the grade 11s and the grade 7s, except in data handling. Grade 11s do a bit better. Data handling's been reinforced, I think, in biology and science and business studies, those other subjects. And there is a difference in algebra. The main focus of FET, a big part of FET maths, I should say, is algebra. And learners do get by through learning procedures off by heart. And obviously they're applying them quite well, fairly well there. It's below grade 3 level. We've just got to keep that perspective too. So what that showed me is that when learners have these acquired learning deficits, these problems from early learning, if they don't get fixed, they prevent progress. So And those are my key findings that I found from these different studies. If we don't address those learning deficits, we block their progress in maths and science. I think the most exciting thing realization that I came to is that 2015 Nick Spall paper that I put the graph up at the beginning. The title of his paper, let's make sure I get it right now, is Falling Behind and Staying Behind, the Case of Insurmountable Learning Deficits. Okay, and what my intervention with the L4E learners showed me is they're not insurmountable. That actually, with a targeted approach, knowing exactly what the learners need through diagnostic assessment, they're not insurmountable. And even more excitingly, grade 10 is not too late to fix them. And yet we have children who are told at the end of grade 9, you can't do maths. You're not good enough to do maths. But actually, it can be fixed. They could do maths with the right input and support. The L4E learners, they caught up between 3 to 6 grade levels within 2 terms, actually. I put within a year, but it's within 2 terms, because we did the baseline in February and we did the summative in September. And just a little aside, of the 7 threads, I focused hugely on the numbers thread. Even though the numbers thread wasn't the lowest achieving one. And what I found is that it multiplied the improvements in the other threads. Because I think, if I remember correctly, I spent one hour session on data handling. And data handling results were fantastic. I think I spent 2 on space and shape. But it was just getting numbers right. And their number skills were horrific. They were totally dependent on their calculators for the simplest of calculations. They had no strategies for actually working with numbers, and so most of my work was around sharing different kinds of strategies for working with numbers, understanding numbers, estimating with numbers, all those kinds of things. So to get back to the topic, okay, what is reflective learning? Well, it's characterized by deep thought, contemplative, deliberative, with reasoning. And the term reflective practice is one that is not unknown in the corporate world in terms of staff training. So it's odd that we don't see it blasted at us from every side in the school environment, because reflective practice is when you have time to think about what you're doing and why you're doing it, and unpacking that and working through that. And so the nature of using the diagnostics forces that reflective learning. What my reflective learning solution does, which is these diagnostics, is it provides direction for what learners actually need. So we create the blueprint map in order to solidify, build, and strengthen their maths knowledge and understanding. So how do we do it? Well, I have to tell you that those research projects that I showed you beforehand, it took me ages to process learner results. They were administered as pen and paper. The Eastern Cape Limpopo one took me 4 months to actually process the data, and that's no good. So what happened is I have now actually partnered with a tech company who have been able to put the diagnostics online. So the first step is that the learners take the test, and they can do it on computers, they can do it on tablets, they can do it on phones even. And the tests, as I said, are designed to measure these 81 conceptual landmarks that run along 7 conceptual threads from grade 1 to grade 9, and to benchmark performance, to give feedback on what level a learner's at grade 3, grade 6, and grade 9 level. We have a diagnostic for the primary school as well, which measures 51 conceptual landmarks that you do in primary school, and it benchmarks grade 1, grade 3, and grade 6 levels. And then we even, because of the nature of the problem, we even have a foundation phase diagnostic, which actually has just 25 conceptual landmarks, what you need to be able to master in maths from foundation phase, and it benchmarks grade 1, grade 2, grade 3, so that you can pick it up right away. I've been working on another project for SchoolNet and the DG Murray Trust the last 2 years, and it's been a delight for me as a former high school teacher to be in grade R and grade 1 and grade 2 classrooms. And what I've seen is the wheels are falling off at the end of grade 1, the last half of grade 1, and the beginning of grade 2. When I go into the schools to do my numeracy tests, everything's great in grade R. It's great in grade 1 when I go there in July, August. When I come in grade 2, all the schools, and I've worked in 12 different schools with thousands of learners, they're all crashing through the end of grade 1 to grade 2. So I can see where those learning deficits actually are starting. So the second step is, once the learners have done the diagnostic, then the teacher can download the feedback instantly, as soon as the last learners submitted their online diagnostic. So as I explained, this is my view of maths, okay? I share it with the kids, because actually learners need to understand how these conceptual landmarks relate to each other, because sometimes you can see you've got a problem with something and there's a lot of red all around it, and if you fix that original part of it, the others all fall into place. So this is an example of the kind of feedback map a learner gets, overview map. The rows of dots are my conceptual threads. The dots along them are the conceptual landmarks, and each landmark is made up of 3 concentric circles. There's a little circle in the middle, an outer one, and one on the outside, and they are colored red or green depending on what level a learner is operating at. So they can see right at a glance where the red spots are, And it will also tell them to what degree they're struggling. What you see happening is a teacher in grade 8 finds that learners can't keep up with something she's introducing. So she thinks, okay, they never got this in grade 7, I'll revise grade 7 work. But what she doesn't realize is that actually they never got it in grade 4. And so when she revises grade 7, she still doesn't enable them to make the connections to it. So this actually targets exactly how far back one needs to go to try and fix it. So this is just a couple of screenshots from the website. So this is a learner's actual results, and I'm sorry the light is not so great, so you can't see. But some of those circles are red and some of them are green. And each one of those conceptual landmarks then gets an actual feedback comment that directs the teacher to exactly what the learner can and can't do. And if you look at this bottom one here, determining factors, when the learner's at a lower level, there's a lot more feedback. So a teacher who knows what they're doing in maths, it's very, very easy to mobilize the resources that that learner needs, because it tells you exactly what they can't do to be able to pick them up. Sorry, there's another page of it, and that's just the numbers feedback report. So a learner gets a feedback report like that on each of the 7 conceptual threads. And then probably more exciting for me is it gets pulled together then for the teacher to be able to analyze it, to design an intervention to actually address those issues. So each teacher receives a class overview report, a threads report, and a landmarks report for each thread. So that's 9 reports. Let me show you quickly what they look like. So there you can see that same little graph. That's a class of 20 learners in a pilot school. It was the first time we ran it online. And the red line shows you the grade 3 level, the yellow line shows you the grade 6 level, and the green shows you the grade 9 overall. And it gives you a little summary of who's operating on which of each of the 7 assessment levels. But more importantly than that, you can drill down to the conceptual threads, and you can see the achievement overall on those conceptual threads. And it's so interesting for me because we have now tested about 1,000 learners, and the same pattern shows every time. Problem solving and algebra are always the lowest. Fractions is always just a little behind, and data handling is usually the best. Interestingly, in this little group of 20, numbers was quite high up there. And then at the bottom here, for each of those conceptual threads, it shows color-coded what percentage of the class is operating on what grade level. So the red little bar at the bottom there, if you put your mouse on it, it tells you the actual percentage, and I think it's 5% in this case. 5% of the class are actually at grade 1 to 2 level. These are grade 9 learners, by the way, at an independent school. The yellow bars show you learners that are at grades operating at grades 3 to 5 level. The pale green shows grade 6 to 8 level, and the dark green shows grade 9 level. So there's an idea of, you can see at your cohort, you can see where the areas of weakness are, and the amount of children that are struggling with it, to know how to prioritize it in terms of fixing it. And then we unpack it even to the furthest degree, and I'm sorry, I'm really bombarding you with serious data here, but so each conceptual landmark, the same kind of structure is provided to the teacher, and you'll notice on this, I don't know if you can see, there's like, I'm seeing 2 little sinkholes on every set of data. That one little patch there of red and orange, can you see it? 1, 2, 3, third bar down, 3rd and 4th. That's around place value and rounding off. And that's a sinkhole I'm seeing on every set of data I get. So that's an area that we need to focus on overall. The other one is down here, and it's on divisibility. And the spread of it is the effect on multiplication, dividing, factors, multiples, questions to do with that. So it gives the teacher an opportunity to use data-driven practice in the classroom with tailor-made data for their class. So step 4, obviously, is the important part, designing and implementing the teaching and learning. And so we're still in the process of working out how we're going to deliver what I did in a kind of digital fashion. And so the focus at the moment is just on the diagnostics, and we are partnering with other people who have solutions and resources to be able to step in and actually address it. But as I say, a maths teacher, who has experience is able to see exactly what each learner then needs. So just to quickly finish off, I think I'm probably going a little bit longer than my time, but just what do I think is important in terms of fostering reflective learning? First of all is a growth mindset. And I have to tell you, if somebody was to ask me, if I was a principal, what would be the first training course I would have my staff do, it would be one on growth mindsets. And I don't know if you're familiar with Carol Dweck's book of quite a few years ago now, but it is really worth reading it. You won't say any longer, this child shouldn't do maths, or this child is a 50%er. They're not going to get anything more than that. A growth mindset opens up to the possibility that any child can learn anything with the right support. And that plays into our theory, Vygotsky's constructivism. I'm just going to flip on, and his zone of proximal development, that actually a learner just needs support and access to resources to be able to learn beyond what they can learn on their own. The other thing that I've learned through all of this is to focus on the big ideas. That if you get the big ideas right, then the little facts and details fall into place. And this is a very interesting paper written by a guy called Charles in 2005, which had a huge impact on maths education globally. He identified 21 big ideas in maths. And it was so well received that in 2006 they organized a conference, a global conference for science teachers, who then compiled their own version of big ideas in science. I would really recommend looking this up. It was published in an educational leadership journal in 2005. Charles's Big Ideas is the search on Google, and it's fantastic. The other idea really is learning trajectories, which has also been a big part of more recent maths education, that actually we track learning progress along these pathways. And a learning trajectory is a pathway really for teachers that involves how do I plan and prepare for the learners to make this learning journey, whereas my conceptual threads are more a pathway for the learners. And this little diagram on the right kind of shows it nicely, that as you are moving along that learning pathway, there are conceptual landmarks that you have to actually conquer and master on your path. There are also conceptual obstacles. They're your misconceptions, your preconceived ideas, your misinformations that interfere with it, and you need to avoid those and actually conquer the conceptual landmarks. And then a critical thing for me always is assessment as learning, and for reflective practice it's essential. Learners need to actually be involved in their own assessment. We need to use self-assessment even for little children. And we need to actually be comparing their self-assessments with our assessments of them in an open way so that they learn to understand how they learn. There's a lot of it is making the news these days now. I'm sure you've heard of the Dunning-Kruger effect because of what's happening in America with Donald Trump. But the Dunning-Kruger effect is, the situation where someone is so ignorant that they are completely unaware of how little they know. And what happens is that there's a pattern, a very clear pattern that happens in metacognitive development, whereby whereby in the beginning when you know nothing, you overestimate yourself. You think you're brilliant at everything. And there's measured, I mean, I've done some of it myself. There's measured research. And then what happens is as you start to learn and you start to know, then you tend to underestimate yourself because you know what actually you could be and you're not there. And that's also not ideal because where you want to get to truly metacognitively understand yourself is where you can properly self-assess and you know where your strengths and your weaknesses are. So sorry, I'm talking ahead of myself. Formative feedback is a vital part of assessment as learning because we're giving those learners feedback all the time that enables them to actually understand their own learning. And then metacognitive activation is that moment where they go from overestimating to underestimating before they develop metacognitive skills that are at a level that they can properly assess each other. And themselves, and one of the struggles I had on this journey was around embracing error. Because learners, well, we live in a culture where actually we don't embrace error. We are ashamed and embarrassed by our errors. We don't like to share them. And that's a big problem when you're learning, because actually it is our errors that actually direct us in terms of where our learning needs to be. So on all of the projects that I've worked with in the schools, I spend a lot of time and energy talking about the value of making mistakes, and that I'm not actually interested in anything that anyone's got right, because there's no job to be done for me there. I'm only interested in what actually people have got wrong, because that tells me what they need. And we need to actually have learners embracing their error and learning from their error so that they can properly progress. So, to finish off, I believe that reflective learning can identify these persistent learning deficits acquired from early grades for the purpose of being able to target remediation. This is a class in Mpumalanga, grade 1 class, 67 learners in one classroom. And look at those little faces, such potential, such expectation of us, and not ideal learning conditions at all. Obviously, a key driver for me is to increase opportunities to access maths and science. That learners have the privilege of choosing not to do maths and science, not being told they can't do it, and they couldn't do it actually because of what happened so long before. To obviously raise achievement in maths and science, because we need that in our country, which would open doors to tertiary studies in STEM fields. But right at the heart of it for me is that reflective practice activates those metacognitive skills. And that is our core business as a teacher, is to light a flame of a love of learning in each of our learners. We use our subjects and our knowledge and our content as a vehicle, but actually at the end of the day, we've been successful when we've created independent, sustainable, lifelong learners. And the way to do that is through metacognitive activation, so that they get excited and interested in how they learn, what they learn, why is it different to other people, what do they need that's different to other people in order to be successful at learning. Sorry, I think I went well over my time, but thank you very much. Thanks very much for the opportunity. Are there any questions? Yes. Yes.
Once you've done, let's say you've got a class of 90, or a group of 90 learners that you've diagnosed.
Yeah.
And you've downloaded and you've received the results.
Yes.
Would you advocate streaming them?
I don't advocate streaming, I have to tell you honestly. There's a researcher, an Australian researcher called John Hattie, who has done a big meta-analysis of research in education over decades, millions and millions of learners involved in it. And he's got an index a ranked index of what makes a difference in education, and streaming is in the negative part of that. It actually it worsens a learning environment. So no, I wouldn't. I actually like mixed ability groups, and I purposefully create mixed ability groups because I think more learning happens when you have that kind of diversity in the classroom.
The purpose of the intervention, you're saying you're going
Same.
to 1 hour?
Same. Yeah, no. Just remember, the learners are part of the process, and they know exactly what levels they're on, what they need, and they have then the resources to access. I mean, I'm obviously very keen to be spreading the word of the intervention, but I have to tell you honestly that intervention that I did with L4E, I don't believe that it's scalable the way we did it, because we invested in relationships with those learners. Those learners are now in third year varsity, and I'm still connected with all 50 of them. They're all over the country in all different institutions. And I have to tell you one little boast. 29 of the 50 got placed in tertiary study in the first year after they left school. We had a mix-up with the Mpumalanga College of Nursing that was going to take quite a few of them, because obviously money was a big problem. More than half of them were orphans and vulnerable children. And those 29, we had 100% pass rate at the end of first year tertiary study, which if you compare with what's happening nationally is unbelievable. I mean, at the same time, that project ran for 3 years, from when they were in grade 10 to grade 12. We had 100% retention rate, and we had a 96% attendance rate over 3 years. 8 of the girls produced babies in that period, and still stuck at school, coming to the program. So there was a lot of emotional energy invested in it, and I'm obviously looking now at how do I take what I can from that to make it a scalable option, because in South Africa you can't be doing anything without people asking about scale. And so my first step in is if we can just identify what the problems are, and we can do that to scale. It takes a quick and easy time to get everybody to do it. I was in Noput last week, which is in the middle of nowhere in the Northern Cape. I don't know if anybody knows where Noput is. And we had 100 learners go through our hands in just the one day, on laptops, on tablets, on phones. The children on computers had clearly never used computers before, and it was really exciting for me to see, in comparison to my teacher development work, how quickly the kids picked up what needed to be done. They were working at full speed with the technology, no problems, within 10 minutes, which was extraordinary. Yes?
Can you minimize the width so that people see your content?
Oh, sure. I don't. Will that help? I wonder. I can't. What you can't see is that I can't see that on here. I've got the main menu. I can't actually see that. Can you? Yeah.
The contact, yes, before the end of the session.
Yeah, it's interesting. I've had surprising success with it. They seem to like the responsibility of being able to diagnose their own issues. And yeah, I haven't actually used it like that with foundation phase learners yet, but I have with the primary school learners. And yes, I had to lay very careful foundations beforehand around culture of error, because kids getting feedback actually operating at grade 1 level when they're in grade 7, we had to be quite sensitive about that. But actually, at the end of the day, they bought into the idea that actually when I know what it is, then I can actually deal with it, then I can fix it. So yeah, thanks.